Alright, this video will compare the use of scheduling in Revit Structure, and the same thing will be compared in Microsoft Excel. And let's see what are the differences between these two softwares. Okay, so first get into here and pick up a structure template. Okay, get into structure and I'm gonna draw a beam, concrete beam. Okay, having a length of 10 meter, so 10 meter. That's it. I'll get into elevation, south elevation. I prefer south elevation, and rebar. Okay, I know these things. For this representation, I'm gonna be drawing a single straight line bar right at the bottom. Before placement, I would like to change this into nearby reference. Okay, just place it here. That's cool. Now I need to know the cover, so either select the beam and understanding the cover from here is 30. Well, I like to change the cover. I'll be picking up this face, maybe 50. Excel. In here, I need the radius of the bar. I need the total length of the bar, which is 10 meter, 10,000. Okay, the radius of the bar. Let me check it out. So just selecting the bar, get to the edit type. Show the bar diameter is 10. Okay, so the radius will be 8. Okay, I like to pin this right onto the top of here, so no matter if I select Revit, that Excel stays right to the top. Alright, next I will have is maybe the total length or the effective length. That shall be this number, the total length minus. We will lose two covers right at the start and right at the end of the beam. So this I said minus 100. So 2 into 50 will make you 100. So this will be the effective length. Okay, that's it. Now get out. Now let's care about the volume. Volume shall be pi. 3.1415, maybe it can have a little bit more accuracy. Pi r square h or effective length. Alright, okay, so this will be the volume right in millimeter cube. So selecting this assistant dividing by 1000 to get to receive. So to get the volume in a centimeter cube, this one shall be in cc, centimeter cube. Alright, so we have the volume here, and next thing what we want here is we need to find out the weight of the bar. Okay, so this could be maybe not tonnage, or just be the mass of the bar. It could be like 7.9, so 7.9 gram per cc. This number shall be multiplied with here the volume, so to get the mass in gram, okay, this number shall be divided with 1000 to get the mass in kilogram. Let's plug this into Revit. Alright, we got everything. Right now we want to get into project browser, and I would like to get a schedule here. Okay, structure. I like to pick up a structural rebar here. Only very few parameters. I need the bar diameter here. I need maybe the bar length. These and all are not important, but the bar diameter is important. Then I would like to have the family type. You want the maximum bar length, and pick any quantity will show the number. The important thing is reinforcement volume, else everything will be provided by your sufficiency. Alright, let me plug this right into the top. Alright, so for now, just get into here. We will have the bar diameter is there, bar length is there, which is 9900. We got reinforcement volume in centimeter cube. Alright, reinforcement volume shows some errors here. Okay, the error is when it's showing 1900 cc, but here, okay, let me check the diameter of the bar here. So the radius is 8. So you could see by schedule it shows that 7.5. So pretty much similar. Now let's see the mass of the bar. So here we get into field, and I like to add a calculated parameter here, and I like to find the mass. This could be not common, it should be structure, and the thing shall be obtained in kilograms, so pick up the mass option here. Alright, okay, so that will be wall reinforcement volume, that number multiplied by 7.9, I think. Let's try. So I edited it. The unit shown right here is in kilogram per meter cube. So you know that the density of the cell kilogram per meter cube is 7900. Hit OK and hit OK. This one is showing 76.14 kilogram. It's the same as that of here, so the thing is very well accurate. So that's all about it. Thanks for watching.